Solve 5z cubed minus 12z squared plus 5z minus 2. We're going to start by looking for a linear factor of the left-hand side using the factor theorem. With the 2 at this end, normally you only have to worry about plus or minus 1 or 2. With the 5 at this end, we might have to worry about 1/5 and 2/5 as well, although the questions are rarely set up so that you have to look for ages. So let f of z be equal to 5z cubed minus 12z squared plus 5z minus 2. Let's try f of 1. That's going to be 5 minus 12 plus 5 minus 2, which is not 0. Let's try f of negative 1. That would give me negative 5, take 12, take 5, take 2, and that's definitely not 0 either. Let's try f of 2. So that would be 5 times 8, which is 40. Take away 12 times 4, which is 48. Add 10, take away 2. And that is 0, which tells me that z minus 2 is a factor. So we know that 5z cubed minus 12z squared plus 5z minus 2 is equal to z minus 2, and then a quadratic factor. Now with 5z cubed at this end, we need 5z squared at this end. This is a negative 2, this is a negative 2, so I know I need plus 1 at this end. Not sure what goes in the middle, so we'll write plus a z. We can find that z by comparing coefficients of z squared. On the left-hand side, we've got negative 12. What's going to give me a z squared over here? I'm going to get negative 10 from there. Plus a gives me that a is negative 2. So we have that z minus 2, 5z squared minus 2z plus 1 is equal to 0. Clearly, one of the solutions is z is 2. The other solution will come from 5z squared minus 2z plus 1 is equal to 0. So let's use the quadratic formula. Z is going to be 2 plus or minus the square root of negative 2 squared minus 4 times 5 times 1, or divided by 2 times 5. So that's 2 plus or minus the square root of 4 take away 20, or divided by 10. So that gives me 2 plus or minus root 16, negative 16, over 10. So z is equal to 2 plus or minus 4i divided by 10. So z is going to be 1/5 plus or minus 2i on 5. So once again, when we got complex roots and we had real coefficients in the original equation, we ended up with a conjugate pair.